Hello everyone, hope you're all staying home safe during this COVID-19 situation. Don't try to go out. Spend as much time to be prepared for the university. This course will be very important for your university, so that's why I'm trying to help you guys at this moment. So in last lecture there were a little bit confusion at the very end, so I'm just going to clarify that. So if you have a polynomial function y equal to x 1 over n, and if n is even and positive, then the graph is going to look like this. If n is positive but odd, the graph is going to look like this. Why? Because if you have a n is equal to even, which is 2, 4, 6, all the even numbers, if you want to take a square root of that, for example, square root of -4 is going to give you a error. It's not a real number, it's going to give you a complex number. That's why this graph only exists in positive y-axis. But if you have a cube root of 3, or your exponent is odd number, for example 3, 5, 7, then your graph will look like this. It will be from negative y to positive y. For example, cube root of -8 is -2, and cube root of 8 is 2. You can have both positive and negative when you have a odd roots. So that's why the graph looks like this. If you have an exponent, negative exponent of a polynomial function, for example y equal to x to the power -1, you can also write it as y equal to 1 over x. And if you have x to the power -2, you can write 1 over x2. Again, if you have odd exponent, which means x is the value x -1, which is odd, your graph will look like this. If it is even, like -2, the graph is going to look like this. What is rational function? Rational function is combination of polynomial function. So fx is equal to px over qx, and both of them has to be polynomial. This is an example: x squared plus 1, x minus 1, and the domain will be any real number but x cannot be 1. Any real number but x not equal to 1. Why? Because in the denominator we have x minus 1. So if we substitute do the function by f of 1, we're gonna get 1 squared plus 1 and 1 minus 1, which is 0. I will try to erase it. Okay, try it again. 1 squared plus 1, 1 minus 1, 2 over 0 is equal to 2 divided by 0, and it is infinite. So that's why we cannot have x is equal to 1 in the domain. Algebraic function is a function which can be represent polynomial function using algebraic operation. What is algebraic operation? Plus, minus, sign, multiplication, division. So root x plus 1 represented by algebraic operators, root x plus 1 minus x, again an algebraic function. This one is both algebraic and rational function. Trigonometric function. Trigonometric function is sin x, cosine x, tan x, and tan x can be written as sin x over cosine x, and the inverse of sin x is cosecant. Cosecant is 1 over sin x, secant is 1 over cosine x, cotangent is 1 over tan x, and also can be represented as cosine x over sin x. And I think you have already learned this SOHCAHTOA to find the formula for sine, cosine, and tan. So S represents sine, C represent tan, C represent cosine, and T represent tan. So sine is opposite over hypotenuse. Opposite over hypotenuse. What is from the graph we can see opposite is y, hypotenuse is 1. Y over 1 is equal to y. So sine theta is y. We can similarly solve by sine 0 degree. So sine 0 degree will be 0, because if the angle is 0 degree, that means the y will also be 0. So 0 divided by any number will be 0. So sine 0 degree is 0. So and now we'll look into the these graphs below. So the fundamental angle for any trigonometric function is 0, 30, 45, 60 and 90, and this all can be represented using two right angle triangle. So in first case, if you have a right angle triangle means 90 degree, so one angle has to be 90 degree. So if one angle is 90 degree and other angle is 45 degree, I will take it up a little bit. Okay, so if one angle is 45, so we'll look into this one triangle first. So if one angle is 90 degree, another angle is 45 degree, the third angle has to be 45 degree because it's right angle triangle and combination of total angle of a triangle is 180 degree. So if adjacent is 1, if opposite is 1, the hypotenuse has to be square root of 2. How we know hypotenuse square is equal to adjacent square plus opposite square? So 1 square plus 1 square is equal to 2. So hypotenuse square is equal to 2. So hype is equal to square root of 2. Now we have the graph. So if you wanna find sine 45 degree, so this is the angle. So hypotenuse will be always opposite of the 90 degrees. So this is always be the hypotenuse, as we all know. So this is the hypotenuse, and if this is the hypotenuse, and if we are taking this the angle, we are considering this 45 degree angle, so opposite of the angle will be opposite. That's why it's called opposite. So if you're considering this 45 degree angle, then this will be the opposite, and hypotenuse will remain same, either we consider this or this. So how much is our opposite? 1. So for example, okay, now we'll try to see how SOHCAHTOA works. Cosine theta will be adjacent over hypotenuse a over h, and in this graph adjacent is x, hypotenuse is 1, so cosine theta will be x. For tan is opposite over adjacent, tan is opposite over adjacent, so it's going to O over a. What is opposite? Y, adjacent x, y over x is equal is the tan. And we can draw another type of right angle triangle, this one, to find 30 degree, 60 degree. This is for sine 45 degree. This is one type. If we have 30 degree and 60 degree, then again this is a right angle triangle, 90 degrees here. So if one angle is 30 degree, other angle has to be 30 degree. Sorry, if one angle is 60 degree, other angle has to be 30 degree, because again is 180 degree for a combination of a total triangle. So let's say if you consider 60 degree, if this is 60 degree, then if we consider 60 degree as the angle, this will be the opposite, and this will be 90 degree always. That means this will be the hypotenuse. So for sine 60 degree, opposite over hypotenuse, opposite is √3, hypotenuse is 2. So that's why √3 over 2, sine 60 degree. Sine 30 degree, so if you consider this angle, now hypotenuse still remains same, this one, but the opposite changes to this. So sine 30 degree will be corresponding to 30 degree angle, 1 over 2. And if it is sine 90 degree, it's gonna be 1, and 1 over 1 is equal to 1, because when the sine is 90 degree, the y is going to be 1. So this is a sine is a periodic function. So what is a periodic function? After one period, the or it goes back to the original point. So sine started off at 0, and after this at 2 pi is going to again start it from here. So 2 pi is the period of the sine function. Is 2 pi, the domain is any real number, range is -1 to +1, and this is how it's going to look like, and this is how the cosine look like. So again, what is periodic function? It returns back to the original point after one period is called a periodic function. So sine started as 0, so it's going here, and it's at 2 pi is again starting another sine function, so that's why it's called a periodic function. Exponential function. Exponential function y equal to b to the power x, and b is greater than 0. That means it's a positive number. Domain will be -infinity to +infinity. Range will be 0 to +infinity. So for example, y equal to 2x and y equal to half x. So y equal to 2x will look like this. So as the value of x increases, the value of y also increases, because the base is greater than or equal to 1. So this is true when base is greater than 1. If base is less than 1 and positive, then as the x increases, y decreases. Why? So let's think our base is 0.5. So 5, and our exponent, let's think, is 2. X is equal to 2, so 0.5 times 0.5 will give us 0.25, which is a smaller number than 0.5. If our base is a number greater than 1 and x is 2, then 5 times 5 will give us 25. So as x increases, the graph will increases, and both the graph, half x or 2x, will have y-intercept at 1, because 2 to the power 0 or anything to the power 0 is 1. So one is increasing function, one is decreasing function, like we learned earlier. Okay. Logarithmic function. So log functions is just opposite of exponential function, or the inverse of the exponential function. So exponential function is y equal to bx. So inverse function of that will be y equal to log bs. So b is the base, x is the exponent. And to solve for x from the log function, y equal to log bx, it can be solved as x equal to b over y. So base over the value of the function. This is the exponential function, y equal to tx. This is the logarithm function. In logarithm function, it goes through x-intercept, y equal to log 2x, and x-intercept is always at +1. And this is again sine function, and it's just showing some shifting up and down of the sine function. So the first graph, sine x plus 1, that means moving sine up by 1. The sine graph, we are shifting it up by 1. So this is how the original sine graph looks like, and if you are moving it up by 1, then this is how it's going to look like. So this value was +1, and this value was -1. So we are shifting up by 1, so we'll add each y point plus 1. So maximum point will be now 1 plus 1 2, and the minimum point will be -1 plus 1 is equal to 0. So this is how the graph is going to look like. And this one, we are shifting the function right by pi over 2. So we are shifting the whole graph right by pi over 2. So sine is starting from pi over 2 and ending at 5 pi over 2. We'll learn about shifting in we already know about shifting. I'll go into a little bit more details in future lectures. And yeah, that's all about it. And again, you should know this shifting. So the maximum value of sine original function is +1 and -1, and in the original graph, and once we shifted it up by 1 +1, we shifted the whole graph by 1, so the maximum value now changed to 2 and 0. Okay, and we have solved a similar question earlier, how to find a vertex in this manner. So we know the vertex, how to find this using completing a square, so I'm not gonna cover this. And this is again some shifting, so this is our original graph, y equal to x square, and y equal to x square 3, so it's the whole graph is shifting 3 units bottom, and this is at absolute y square minus 3, so that means we cannot have any negative y value. The graph is going to look like this. And in next lecture I will be covering this, the vertical and horizontal stretch. So that will be for today. Stay home, stay safe, and don't forget to like and subscribe. Thank you.